Hello, Chemistry 20. This is our fifth lesson in the Quantities in Chemical Reactions unit. This is Combustion Reactions. In this lesson, we will look at complete and incomplete combustion and determine the products of a complete combustion reaction. Complete combustion reactions have a sufficient amount of oxygen present, meaning there is more than enough oxygen required for the reaction to occur. Incomplete combustion is a reaction that occurs with insufficient amount of oxygen, meaning there is not enough oxygen present. In Chemistry 20, we will focus on complete combustion reactions, and we will also focus on the combustion of hydrocarbon molecules, meaning molecules that are composed of hydrogen and carbon. The general equation of a complete combustion reaction is always the same. It is a hydrocarbon plus oxygen, O2 gas, forms carbon dioxide, CO2 gas, plus water vapor, H2O gas. The only chemical species that may differ in the chemical equation is the hydrocarbon. For example, it could be the combustion of propane, or it could also be the combustion of octane. The only difficult component when writing complete combustion reactions is balancing the chemical equation. Predicting combustion reactions. Step number 1, we have to determine that a combustion reaction is occurring. For example, the question may say the combustion of propane. It may also say propane is being burned, or it could also say propane is reacting with oxygen. Once we have determined that a combustion reaction is occurring, we have to write the products of the chemical reaction. They are CO2 gas and H2O gas. Step number 2, we have to balance the chemical equation. We want to first balance carbon atoms, then balance hydrogen atoms, and then finally balance oxygen atoms last. And then finally, we need to double check our answer to make sure the chemical equation is balanced and all species have physical states. Example number 1. Write the complete combustion reaction of liquid propane, then of butane gas, and finally octane gas. Pause the video and attempt this example. In our first chemical reaction, we have the following answer. Propane is C3H8 and a liquid because it was stated in the question. We are reacting it with oxygen gas and forming CO2 gas and H2O gas. In order to balance this chemical equation, we have to balance carbon first. There are 3 carbons on the reactant side, so we will put a coefficient of 3 in front of CO2. We now have to balance hydrogen. There are 8 hydrogens on the reactant side, so we will put a coefficient of 4 in front of H2O. As a result, on the product side, we now have 4 oxygens plus 6 oxygens for a total of 10 oxygen atoms. So we will then put a coefficient of 5 in front of O2. Our chemical equation is now balanced. For our second chemical equation, we have the following answer. First, we have to balance carbon. There's 4 on the reactant side, so we will put a coefficient of 4 in front of CO2. We then have to balance hydrogen. There's 10 on the reactant side, so we will put a 5 in front of H2O to give us 10 on the product side. If we count the number of oxygens on the product side, we have 5 plus 8, which gives us a total of 13. Now 13 is an odd number and very difficult to balance. But if we put a 6.5 in front of O2, that also gives us 13 on the reactant side. Unfortunately, we cannot have a 6.5 coefficient because we typically work with whole numbers. So at this point in time, if we multiply every coefficient in the chemical equation by 2, we would have the resulting answer. 2 C4H10 plus 13 O2 forms 8 CO2 plus 10 H2O. Our chemical equation is now balanced. For our final chemical equation, we have the following answer. First, we have to balance carbon. There is 8 on the reactant side, so we will put a coefficient of 8 in front of CO2. We now have 18 hydrogens on the reactant side, so we will put a coefficient of 9 in front of H2O to get 18 hydrogen atoms on the product side. We have 9 oxygen atoms plus 16 oxygen atoms, giving us 25 oxygen atoms on the product side. I then have to put a 12.5 coefficient in front of O2 on the reactant side to get 25 oxygen atoms. Again, I cannot have a coefficient of 12.5. I need whole numbers, so I must multiply every coefficient in this chemical equation by 2 to get the resulting answer. Our chemical equation is now balanced. Moving forward, we will explore the concept of moles and molar mass.